So this is the third session on rigid body kinematics. So this is in continuation of the second video on rigid body kinematics. So in this session, I'll take up some problems on angular velocity calculation of rigid body in plane motion using the formula for omega equal to relative normal speed by separation, as was discussed in the second video on the previous video on this chapter. So if you want to see this session 3, for that first you must refer to session 2, then only you must come here. If you know the result, then you can directly come here. But if you don't know the result, you first go through session 2 and then come to third session on this rigid body kinematics. Okay, fine. So the formula which will be used will be this working formula. I'll state here. M is some rigid body which undergoes plane rotation with respect to some frame F. Its angular velocity omega at certain instant is given by a formula as omega equal to relative normal speed by separation. Omega is equal to relative normal speed upon separation. Relative normal speed by separation. This is the formula which is going to be used. Okay. The proof of this formula has been given in second session on rigid body kinematics, in the second video on rigid body kinematics. So by using this, so the proof, if you don't know the proof also but you know the result, then you can use it. Okay. So I'll take up some questions on this chapter. Okay, on this concept. So question is this: a rigid rod of length L equal to 2 meter rotates in a vertical plane with respect to ground. Rotates in vertical plane with respect to ground. The velocities of its two ends A1 and A2 are as given. A1 and A2 with respect to ground are as given. In each case, find the angular speed and its sense. With respect to ground at the given instant. Okay, so this is the question. So in this question there will be 8 subparts, A, B, C, D, 8 questions. Okay, this I'll rub it. Okay. So there are 8 questions on this concept. Okay, in this video, I'll take up the question one by one. Okay. The first question is this, part A. Yeah, so in all these parts, all these questions, instead of F frame, we have the ground frame. In all these questions, instead of F frame, we have the ground frame. Instead of M frame, we have the rod frame. Okay. So this common to all the 8 sub questions. Okay. So sub case A is this. This is the rod, 2-meter long rod. This is the end A1. This is the end A2. Velocity of A1 is say right angle 10 meter per second. A2 is say rightward, say at say 14 meter per second. So this we have to specify the value of omega. So velocities of A1 and A2 are both perpendicular to this rod. So omega is equal to relative normal speed by separation. The normal velocity of A2 is the component of velocity of A2 normal to rod, that is just 14 sine 90 degree, which is just 14 meter per second rightward. And normal speed of A1 is 10 meter per second leftward. So from the theory of relative velocity, from the definition of omega, omega is equal to relative normal speed by separation. From the theory of relative velocity, relative normal speed will be 14 plus 10, 40, 24 because they are in opposite directions. So 14 plus 10 by 2, 24 by 2, 12 radian per second is the first answer. Now what is the sense of omega? You can see this is going rightwards, this is going leftwards. So after a short time, rod will become something like this. It will tend to rotate in a clockwise sense. So sense of omega is also clockwise. This is the answer to the part A of the question. Okay, fine. Now we take a part B. Part B. Part B is this. Part B is this. 8 meter per second. This is 10 meter per second. Both the velocities are perpendicular to the rod, okay? Both the velocities are perpendicular to the rod, fine? So this also omega is equal to relative normal speed by separation. Normal speed of A2 is simply 8 sine 90 degree, that is 8 meter per second leftward. Normal speed of A1 is 10 meter per second rightward. They are in opposite directions. So relative normal speed is equal to 10 plus 8, 18. 18 meter per second from the theory of relative velocity. 18 by 2, that is equal to 9 radian per second. This is the answer. Now sense of this rotation will be anti-clockwise, as you can see it, because this is going leftward, this is going rightward. So after a very short time, rod will become something like this. It will tend to rotate in anti-clockwise sense. So sense of omega is also anti-clockwise. Alright. So A and B I have solved, okay? It's alright, fine. I'll rub this one, okay? Now I'll take part C of the question, part C. Part C is this. This is A1, this is A2, 2 meter. A1 is equal to 3 meter per second rightward. A2 is rightward direction, same direction, rightward again. Say at 19 meter per second. So this also we have to tell the value of omega. So again, normal speed of A2 is 19 rightward, 19 sine 90 degree. Normal speed of A1 is 3 rightward, 3 sine 90 degree. They are in same direction. So from theory of relative velocity, relative normal speed will be 19 minus 3. This 19 omega will be written as 19 minus 3 by 2. That is simply 16 by 2. That is equal to 8 radian per second. And you can see the sense will be clockwise because this here, this is moving at a larger speed, rightward speed, this is going at a lesser rightward speed. So in short time, the rod will become like this. It will tend to rotate clockwise. Sense of omega is therefore clockwise. Alright, fine. So this is the answer to this part C of the question. This is the answer to part C of the question. Alright, fine. Okay, fine. Now I'll rub this one. Now I take the question on part D. Part D is this. This is 24 meter per second rightward, and this is 2 meter per second rightward. All these velocities are with respect to ground. So omega is again equal to relative normal speed by separation. Normal speed of A1, A2 are both 24 and 2, both rightward with respect to ground. 24 meter per second and 2 meter per second rightward with respect to ground. So in the same direction. So omega is relative normal speed will by separation. From the theory of relative velocity, relative normal speed will be 24 minus 2. 24 minus 2 by 2. So 12 by 2. This becomes 24 minus 2 becomes 22. 22 by 2 becomes 11. 11 radian per second. The sense of this omega will be anti-clockwise because this is moving at a larger rightward speed, this is going at a lesser rightward speed. So short time later rod becomes something like this. It's going to rotate in anti-clockwise sense. So omega is equal to 11 radian per second in anti-clockwise sense. So omega is equal to 11 radian per second in anti-clockwise sense. Okay, this is also clear. I'll grab this one, okay. Now part E of the question is this. This is the rod A1, A2. 2 meter is the rod length. A1 is going leftward, say at 8 meter per second. A2 is also going leftward, say at 12 meter per second. Both these velocities are with respect to ground. Now we have to find omega. Omega is equal to relative normal speed by separation. They are in the same direction. So from the theory of relative velocity, relative normal speed will be 12 minus 8. By separation is simply 2 meter. 4 by 2, 2 radian per second. This is the answer. What is the sense? Sense will be anti-clockwise because this is going at a lesser leftward speed, this is going at a larger leftward speed. So in short time rod will become something like this. It will tend to rotate in a clockwise sense. The sense of omega will therefore be, it will be in anti-clockwise sense, not clockwise, anti-clockwise sense. Okay, fine. I love this one. And part F question is this. This is the rod A1, A2, 2 meters. This is equal to 14 meter per second, again right angle. This is at 3 meter per second, again right angle. Now we have to tell the value of omega. Omega will be equal to relative normal speed by separation. Both the normal speeds are in the same direction leftward. So relative speed will be equal to 14 minus 3 from the theory of relative velocity by separation 2 meter. 11 by 2. 14 minus 3, 11 by 2, 5.5. 5.5 radian per second. Sense will again be clockwise because this will go more, this will go left. This will move leftward more in small time. So sense will be this clockwise. So this is the answer to this question. Okay. So 6 parts of question 1. Okay. I'll take up question 2. This I'll rub it. Okay. Fine. I'll take up question 2. Question 2 also I'll specify now. Okay. So rigid rod A1, A2 rigid rod A1, A2 of length L equal to 4 meter rotates in a vertical plane with respect to ground at a given instant rod is horizontal as shown. Also, the velocities of points A1 and A2 are as given. In each case, find the angular speed and sense of its rotation. Find the magnitude of angular velocity and its sense with respect to ground. Angular velocity and its sense with respect to what? Ground. Okay. In this question there will be 4 parts, A, B, C, D. Okay. Now this is a little bit fine. So again in this question, formula will be based on this the question will be based on this formula. So I'll draw the ABC. There will be 4 questions on this second question, 4 subparts. I'll draw each of them one by one. Okay, so again in this noted, all these 4 subparts of the question, instead of F frame we have the ground frame, and instead of M frame we have the rod frame. Okay, fine. Now question 2, this question 2. Now I could take the part A, I draw the diagram. Part in the diagram is something like this. This is the rod, this is A1, A2. 4 meter is the rod length. Length of rod is given to be 4 meter. Okay. So velocity of A1 with respect to ground is at the given instant is 10 root 2 meter per second at an angle of 45 degree. And velocity of A2 is given to be some value, say 20 meter per second. But this angle is not given. This angle is not specified. This angle theta is unknown. This is the situation. Okay. Length of rod is 4 meter. Fine. 4 meter is the rod length. So now we have to find the value of omega. So omega is equal to relative normal speed by separation. Now to know the we have to know the relative normal speed, we must know the normal velocities of A1 and A2. Normal velocity of A1 is component of velocity of A1 normal to this rod, that is 10 root 2 sine 45 degree. That is simply 10 meter per second upward. Now we have to know the normal velocity of A2. For that we must know the angle which the velocity of A2 makes with the rod. Let's call it say theta. Now how to find theta? For theta you know that this rod is a rigid body. Its length is constant. Distance between the points A1 and A2 is constant 4 meter. So component of velocities of A1 and A2 along this rod A1 A2 they are equal in magnitude and direction both. The component of velocity of A1 along this rod is 10 root 2 cos 45 degree. That is same as 20 cos theta. Now cos 45 degree because 1 by root 2 goes away. 10 equal to 20 cos theta. That meaning cos theta is equal to 10 by 20 half. So that means theta is equal to 60 degree. So now omega is equal to relative normal speed by separation. So you must know the normal speeds of A1 and A2. So I draw the diagram here. Normal speed of A1 will be 10 root 2 sine 45 degree. That is 10 meter per second in upward direction. And normal velocity of A2 will be 20 sine 60 degree. That is 10 root 3 meter per second in upward direction. This is the normal speed of what? A2. This is the normal speed of A1. And this is the normal speed of A2. Now you can see they are in the same direction. This is more than this. So omega is equal to relative normal speed by separation. From the theory of relative velocity, relative speed will be 10 root 3 minus 10. They are in the same direction. 10 root 3 minus 10 by separation, which is simply 4 meter. This is the answer to this first part of the question, part A. 10 root 3 minus 10 by 4 radian per second. And the sense of rotation will be anti-clockwise. Because this is moving at a larger speed, this is going at a lesser upward speed. So the rod will rotate like this, anti-clockwise sense at this instant. So this is the answer to part A of the question. So this is the answer to part A of the question. Okay. Now part B I'll take up. Part B of the question. Part B is this. This is A1, this is A2. 4 meter is the rod length. This angle is say, let us call it say, this is say 16 root 2 meter per second. 16 root 2 meter per second. Say at an angle of 45 degree. And let's say the velocity of this is equal to say 32 meter per second. Again, direction, this velocity is unknown. It is in this plane, but its direction is not given. Okay. Now again, we have to find the value of omega. So omega is equal to relative normal speed by separation. So you must know the normal velocities of A1 and A2. Normal velocity of A1 will be component of this along normal to this rod, that is 16 root 2 sine 45 degree. That is 16 root 2 into 1 by root 2. That is 16 meter per second in upward direction. Now we have to know the normal speed of A2. For that we must know the angle which this velocity makes with this rod A1 A2. Let this angle be noted by phi say. Now how to find phi? Distance between A1 and A2 is constant. It's a rigid body. So component of velocities of A1 and A2 along this rod should be equal in magnitude and direction both. Component of velocity of A1 along this direction will be 16 root 2 sine cos 45 degree. That is simply 1 by root 2, which is equal to 32 into cos phi. Root 2 goes away. So cos phi becomes 16 by 32. 16 by 32, that is 1 by 2. So phi becomes equal to 60 degree. Alright. Phi becomes how much? 60 degree is the value of phi. Okay. So I'll grab this one. Fine. So normal speed of A2 will be 32 sine phi. So normal speed of A1 is how much? 16 meter per second in upward direction. And normal speed of A2 is what? 32 sine phi in downward direction. Sine phi is simply root 3 by 2 sine 60 degree. That is equal to 16 root 3 meter per second. Okay, this is in downward direction. Now both these normal velocities are in opposite direction. So from theory of relative velocity, omega is equal to relative normal speed by separation. 16 plus 16 root 3 by 4. Separation is 4 meter. So this becomes, force cancels out. 4 into root 3 plus 1 radian per second is therefore the required answer. Okay, and sense will be, you can see it is clockwise sense. It has to be a clockwise sense because this is going upward, this is going downward, so rod will rotate like this in a clockwise sense. This is the answer to this part C of the question, part B of the question. Fine. This also I'll rub it. I'll take a part C of the question. Part C is this. This is the rod A1, A2. 4 meter is the rod length. Velocity of A1 is given to be 6 root 2 meter per second at an angle of 45 degree. A1 is given to 6 root 2 meter per second at an angle of 45 degree. And velocity of A2 is given to be, its angle is known, 60 degree. But speed of A2 is not known. Only motion direction of A2 is known in this direction. But its speed V is unknown. Again, we have to find omega in this case. Again, omega is equal to relative normal speed by separation. So to know omega, we must know the normal velocities of A1 and A2. Normal velocity of A1 will be 6 root 2 sine 45 degree, that is 1 by root 2. That is simply 6 meter per second in upward direction. Now we have to know the normal speed of A2, that is equal to V sine 60 degree. But to know this normal speed, we must know V. So how do we determine V? A1, A2 is a rigid body, so distance between A1 and A2 is constant. So component of velocities of A1 and A2 along this rod, they must be equal. So component of velocity of A1 along this direction is 6 root 2 cos 45 degree. Cos 45 degree is simply 1 by root 2. That is same as V cos 60 degree. V cos 60 degree. This root 2 cancels out. Cos 60 becomes half. V becomes 12 meter per second. Okay. So normal speed of A2 is how much? Normal speed of A2 becomes how much? This will be equal to 12 sine 60 degree. Sine 60 degree is root 3 by 2. So this becomes 6 root 3 meter per second in upward direction. So normal velocities of A1, A2 are both in upward direction. But this is less, this is more. So omega is equal to relative normal speed by separation. That is just equal to 6 root 3 minus what? 6 by 4 radian per second. And what will be the sense of this? Since this is more, no? This is more. So the rotation sense will be anti-clockwise. Sense of omega will also be anti-clockwise. This is the required answer. This you can simplify it slightly, okay? 2 will cancel out, fine. I'll rub this one, okay? And part D of the question is this. This is the part D of the question. Again, this is a rod 4 meter length. A1, A2 are its two end points. Velocity of rod is given to be, say, 12 root 2 meter per second at an angle of 45 degree. And speed of A2 is V. That is at an angle of 60 degree. Again, we have to determine the value of omega. So omega is equal to relative normal speed by separation. So first we must know the normal speeds of A1 and A2. Normal speed of A1 will be 12 root 2 sine 45 degree. 12 root 2 sine 45 degree, that is 1 by root 2 in upward direction. So this is 12 meter per second in upward direction. So normal speed of A1 is how much? 12 meter per second in upward direction. This is normal speed of point A1. Now we must know the normal speed of A2. For that we must know V. How to determine V? Distance between A1 and A2 is fixed, constant, 4 meter, rigid body. So component of velocities of A1 and A2 along this rod must be equal in magnitude and direction both. Component of velocity of A1 along this rod is 12 root 2 cos 45 degree, that is 1 by root 2. That is same as V cos 60 degree. V cos 60 degree, that is equal to just V by 2. And root 2 cancels out. So V becomes 24 meter per second. Okay. So normal speed of A2 will be how much? Normal speed of A2 will be, it will be 24 sine 60 degree, that is 12 root 3 meter per second. In which direction? Downward direction. Now the omega is equal to relative normal speed by separation. I'll wrap this one. So normal speeds of a1 into in opposite direction. So from theory of relative velocity, omega is equal to relative normal speed by separation. So this becomes 12 plus 12 root 3. 12 plus 12 root 3 by 4 radian per second. And what will be the sense? Sense will again be clockwise, because this downward is going upward, it will rotate clockwise. This becomes clockwise. So this is the required answer. Fine. So in this first video, two questions have been taken. In part 1 of the question there were 6 subparts, and part 2 there were 4 subparts. So this was the third session on rigid body kinematics. So I have taken these questions, okay. So now in fourth session I'll take up some more problems on this angular velocity calculation, okay. So this I close it here. Fine. You can go through it. If you understand it, you will have great advantage, okay. So I close it here. Fine.